Welcome to the course on Introduction to Electrical Engineering. We will have a lecture 20 today on two port network part 3. So, we will of course talk about today about the relationship among various two ports parameters. Then we will talk about series parallel connection of two port network, followed by exercise and numerical problems and followed by references. So, coming to like we already discussed about definition of two port circuit, that the following linear 4 terminal circuit containing no dependent sources, we call it network. So, you can have this as a network, two port network. So, we have like a input voltage V 1 with the current of I 1 and of course, return current of I 1 dash, and similarly for output port we have V 2 and current with the I 2 and then I 2 dash, where we can say I 1 equal to I 1 dash and I 2 equal to I 2 dash like. Well, so the terminal A B constitute the input port, usually we call it, and the terminal C D constitute the output port. Well, of course, I mean this is the same network, you can call it with the notation of typically of V 1 I 1 and V 2 I 2. So, no external connections exist between the input and output port, that is one important condition, and the two port model is used to describe the performance of the circuit in terms of the voltage and current at the input and output ports. Two port circuits are used in many electrical fields like communication, control system, power system and electronics system, and they are also used for facilitating cascade design of more complex systems. That is the reason why we really go to for this kind of analysis and treatment. And there are 4 terminal variables, namely V 1, V 2 and I 1, I 2, and only 2 of them are independent, other 2 are dependent on them, and hence there are only 6 possible sets of two port parameters corresponding to these 6 variables. So, that comes as a 4 C 2, considering that 4 variables and 2 are independent. So, that becomes 4 into 3 by 2 into 1, that is 6. So, there can be 6 set of parameters by which this port you can call it the variables can be correlated and can be solved. So, that 6 port parameters are Z, we call it impedance parameters, Y admittance parameter, H hybrid parameter, G inverse hybrid parameter, T for transmission parameter and small t for transpose, or you can call it inverse transmission parameters. So, these are 6 port parameters of 6 category. So, starting from first, we call it impedance or Z parameters for this network, where input is like V 1 I 1 and output is V 2 I 2. And for impedance parameters, we already discussed it, how we really define. We define V 1 V 2 in terms of your I 1 I 2 and with the impedance parameters Z 1 1 and Z 1 2 and Z 2 1 and Z 2 2, and we call it this all Z I J, all 4 elements are in ohms because they are impedance. So, for two port network 4 parameters are generally required to represent this circuit, or we call it two port network. Now, the another set of parameters we call it like admittance or Y parameters, because Y is the notation for admittance we normally follow in electrical engineering. So, again here V 1 I 1 and V 2 I 2 is the bit between the two ports, and here of course, in Y parameter or admittance parameter we define the current of input output I 1 I 2 in terms of V 1 V 2 with the admittance parameter Y 1 Y 1 1 Y 1 2 and Y 2 1 Y 2 2, where Y I j is in Siemens, that is the unit for admittance like. So, all parameters are in admittance like. So, third side of parameters, because we call it hybrid parameter or H parameters, and certainly as the name suggests is a hybrid of different parameters, I mean like we can call it like. So, here we represent of course, the variables V 1 and I 2 in terms of I 1 and V 2, and the parameters of course, hybrid parameter are H 1 1, H 1 2, H 2 1 and H 2 2, where H 1 1 is your admittance impedance like in ohms, H 2 2 is the admittance in Siemens, and H 1 2 and H 2 2 are of course, the scalar because they are the gains, I mean like typically. So, they are not of course, either impedance or admittance, and these parameters hybrid parameters are certainly used for the some analysis, especially the electronic circuit like transistor circuit, there we prefer to use these H parameters. So, this is third set of parameters like. Now, coming to fourth set of parameters, we call it inverse hybrid or G parameters, because G we take a just inverse of H. So, here we of course, take I 1 and V 2, there we have taken a typically parameters of your V 1 and I 2. Here we take I 1 V 2 and in terms of V 1 I 2, and parameters are G 1 1 and G 1 2 and G 2 1 and G 2 2, where G 1 1 is a admittance in Siemens and G 2 2 is impedance in ohms, and G 1 2 and G 2 1 is again the scalars, in the sense they are ratio as a gains like or so on. So, this is fourth set of parameters. Now, coming to fifth set of parameters, that we call it transmission parameters, or we denote like a T parameters. Again they are defined like in terms of input parameters, like V 1 V 2 variables are defined in terms of V 2 minus I 2, and these parameters called ABCD parameters, where V is in ohms, that is admittance, and C is in Siemens, that is B is impedance in terms of ohm, and C is admittance in Siemens, and A and D again are the scalar parameters, means these are the gains, like typically a kind of voltage and current gains like. So, this is the typically fifth set of parameters. Then there is a sixth set of parameters, we call it inverse transmission parameters, or we call it D, or we normally call it T parameters, and these are again defined in terms of V 2 I 2, because that was V 1 I 1, this is V 2 I 2 in terms of V 1 minus I 1, and these parameters of course are inverse. So, they call it A 1 dash, B 1 dash and C 1 dash, D 1 dash, and here you will find B 1 dash in ohms, that is impedance, and C 1 dash is in Siemens, that is your admittance, and A dash and D dash are the scalars, in the sense they are also again the gains, or you can call it the ratio of the two variables, either voltage or currents like. So, these are the 6 sets of parameters for this 2 port network, and now there are finding the methods of these 2 sets of 2 port parameters. First method is calculate or measure by invoking appropriate short circuit or open circuit conditions at the input and output, which we already discussed for majority of parameters in the last 2 lectures, and that is one way. And the second method is derive the parameters from another set of 2 port parameters. So, it may happen that you might be knowing the parameters for one set, then you can correlate the parameters in terms of another set of parameters. So, these are the 2 methods how to find the parameters of your 2 port network about in terms of like a 6 set of parameters like. So, now coming to typically first method. So, finding typically choose the Z parameters as the illustration here, where we are giving a voltage source as V 1 and current flow is I 1, and we keep the secondary open, that what we will talk about here. So, the basic equation we can say V 1 is in terms of Z 1 1 I 1 plus Z 1 2 I 2, and V 2 is your Z 2 1 I 1 plus Z 2 2 I 2. These are the basic equation in scalar form of these Z parameters, and if we keep I 2 equal to 0, means the output terminal is open, then we can define from the equation. If I 2 is 0, so from first equation we say V 1 is Z 1 1 I 1, or we can say Z 1 1 is equal to V 1 upon I 1, where I 2 equal to 0, and we define this as a input impedance. And from the second equation, if I 2 is 0, so we call it V 2 equal to Z 2 1 I 1, and Z 2 1 from this becomes V 2 upon I 1, where I 2 is 0, and this we call it the transfer impedance, because we are taking output voltage and input current. Previous case we are taking input voltage and input current like. So, with this we get 2 impedance parameters. To get another 2 typically parameters, we keep the input I 1 0 means input open circuit, input port is open, and we apply a voltage source V 2 at the output. So, now from the same equation we say now typically V 1 is equal to Z 1 2 I 2, because I 1 is 0. So, we say Z 1 will be Z 1 2 will be V 1 upon I 2, where I 1 equal to 0 means input is open circuited, but this is the voltage reflected because of excitation of the output terminals. And similarly, V 2 will be Z 2 2 I 2. So, Z 2 2 will be V 2 upon I 2, where I 1 is 0, that we call it output impedance. So, when the 2 port does not contain any dependent source, then we can say Z 1 2 equal to Z 2 1. So, this is a method how we can get by this 2 port network by making a measurement and applying the appropriate voltage to this network like also. So, that is a method to find out the Z parameters like. Now, Z 1 1 and Z 2 2 are called driving point impedances of input and output, and Z 1 2 and Z 2 1 are called transfer impedance, and where Z 1 1 equal to Z 2 2. So, the 2 port circuit is said to be symmetrical, and when the Z 1 2 equal to Z 2 1, this called 2 port circuit is called a reciprocal circuit like. Now, that was the first method. The same way we discussed already in the last couple of lectures how you can find out the parameters by making a measurement or doing the experiment of the all 6 sets of parameters. The another method to find out the parameters is the 6 sets of parameters relate the same input and output terminal variables, hence they are interrelated. So, that gives us, say if you have to know the parameter by one method, you should be able to find out the parameters for like another set of parameters. So, a systematic procedure for obtaining a set of parameters from another one is given as follows for the reference. So, typically first step is arrange the given 2 port parameters in the following standard form, typically k 11 V 1 as a generalized equation plus k 12 I 1 plus k 13 V 2 plus k 14 I 2 equal to 0. That is the first equation in terms of these variables, and the second equation is k 21 V 1 plus k 22 I 1 plus k 23 V 2 plus k 24 I 2 equal to 0. I mean, looks like there are 2 equations, looks to be like a 4 unknown, but we already talk about that out of these 4, 2 are dependent and 2 are independent variables. So, virtually 2 equations are required for solving the 2 unknown variables like. So, the second step separate the independent variable and dependent variable of the desired parameter set, and the third step define the solution of the dependent variable vector. So, now coming to interrelationship between the parameters of the 2 port network. So, coming to like typically how they are the typically with the first example is Z parameters in terms of pi y parameters. So, Z being the impedance and y being the admittance. So, we say Z is equal to inverse of Z matrix is equal to inverse of y matrix, and we can expand this matrix in terms of elements like Z 11 to Z 12, Z 21 and Z 22 as a inverse of y 11, y 12 and y 21 and y 22 inverse of this y matrix, and from which we get the typically the value of Z 11 equal to y 22 divided by delta y and Z 12 equal to minus y 12 delta y and Z 21 minus y 21 upon delta y, and y 2 Z 22 is y 1 divided by delta y, where of course, the delta y is here is a determinant of your this matrix, that is your y 11 minus y 22 y 11 into y 22 minus y 1 to y 21. So, that is a determinant of this matrix delta 1. Now, we can have another set of this typically Z parameters in terms of ABCD parameters. So, from the governing equation we can say of your transmission parameters like ABCD parameter, we can write the I 1 equal to C V 2 minus D I 2 and V 2 equal to 1 upon C I 1 plus D upon C I 2. So, similarly, from another governing equation we can write V 1 equal to A B V 2 minus B I 2, and from which we can say the V 1 equal to 1 upon C I 1 plus D upon C I 2 into A minus B I 2, or this we can expand it as a function of I 1 I 2. So, it is a V 1 equal to A upon C I 1 plus A D minus V C upon C into I 2. So, from which of course, we can compare these 2 equations with the governing equation of Z parameters. So, we can say where the Z 11 will be A upon C and Z 12 will be A D minus B C upon C, and Z 21 will be 1 upon C and Z 22 will be D upon C, and this we can write in matrix form now Z matrix Z 11 Z 12 and Z 21 and Z 22 is equal to the elements of this matrix A upon C in terms of transmission parameter A D minus B C upon C and 1 upon C, and the last element is D upon C. So, that is in you can call it the impedance matrix in terms of your transmission line parameters like. So, now we can have even a Z parameters in terms of hybrid parameters. From the governing equation of H parameter network, we write equation like V 1 equal to H 11 I 1 plus H 1 2 V 2 and I 2 equal to H 21 I 1 plus H 2 2 V 2, and from the this equation second equation we can write V 2 equal to minus H 2 1 upon H 2 2 I 1 plus 1 upon H 2 2 into I 2, and from first equation we can write now V 1 equal to H 1 1 I 1 plus H 1 2 V 2, and this V 2 value we can keep it here in this equation. So, this equation becomes your typically your you can call it your V 1 equal to H 1 1 I 1 plus H 1 2 in bracket minus H 2 1 H22 I1 plus 1 upon H22 I2, and that is you can call it like a V1 equal to delta H upon H22 I1 plus H12 H22 H11 H12 divided by H22 into I2, and comparing equation these two equations, we can say the governing equation for Z parameter will be Z11 equal to delta H upon H22 as Z12 equal to H12 upon H22 and Z21 minus H21 upon H22 and Z22 1 upon H22, where the delta H again here also is the determinant of H matrix H11 minus H11 into H22 minus H21 into H12. So, that is the relation you can call it between hybrid parameters and impedance parameters. So, in matrix form this becomes Z impedance matrix becomes Z11, Z12 and Z21, Z22 equal to delta H upon H22, then H12 upon H22 and H21 upon H22 and 1 upon H22. Now, the y parameters in terms of Z parameters. So, we know I equal to y into V, or we can say y Z into I, or we can say V equal to where the because V equal to Z into I. So, we can say y equal to Z inverse, and we can say the y matrix in matrix form with the elements is y11, y12 and y21, y22 equal to inverse of Z11, Z12 and Z21 and Z22. And this taking a inverse of this of Z matrix, we can say y11 equal to Z22 upon delta Z and y12 equal to minus Z12 upon delta Z and y21 equal to minus Z21 divided by delta Z and y22 equal to Z11 by delta Z, where delta Z is a determination of Z matrix, that is Z11, Z22 minus Z12 into Z21, and in matrix form we can write this the y matrix y11 and y12, y21 and y22 equal to Z22 divided by delta Z minus Z12 divided by delta Z and minus Z21 by delta Z and Z11 divided by delta Z. So, now we can say y parameters in terms of ABCD parameters. So, utilizing the ABCD parameters representation, the governing equation we can say is V1 A V2 minus B I2, and giving this I2 equal to minus 1 upon B into V1 plus A upon B V2, and we can say now I1 is equal to C V2 minus D V2 D I2 and equal to C V2 minus D, putting a value of I2 here, it will be minus 1 upon B into V1 plus A by B into V2, and now we can write this equation I1 equal to D upon B into V1 minus AD minus BC upon B into V2. And comparing these two equations, we can say y parameters will be y11 D upon B and y12 will be minus AD minus BC upon B and y22 will be 1 upon B and y22 A upon B. And in matrix form we can say the your admittance parameter in terms of transmission line parameters. So, they are A y11, y12 and y21, y22 will be your D upon B minus AD minus BC upon B and minus 1 upon B and A upon B. So, this is your y parameters in terms of transmission line parameters. So, now y parameters in terms of your h parameters. So, governing equation for h parameter network is V1 equal to H11 I1 plus H12 V2, and from this we can say we can find out I1 equal to 1 upon H11 V1 and plus minus H12 divided by H11 V2, and we can say similarly we can write I2 equal to H21 I2 plus H22 V2, from which we can keep the value here in terms of V1 V2. So, I2 will be H12 in bracket 1 upon H11 V1 minus H12 upon H11 V2 into I1 plus H22 V2, and finally, this I2 will be equal to H21 upon H11 into V1 plus H11 H22 minus H12 H21 divided by H11 into V2, and from this we can write this in terms of finally y11 equal to 1 upon H11, y12 equal to minus H21 H12 divided by H11 and y21 equal to H21 divided by H11 and y22 equal to H11 minus H11 H22 minus H12 H21 divided by H11, and in matrix form it can be written like y matrix parameter in terms of hybrid parameter. It can be y11 y12 into y21 and y22 equal to 1 upon H11 minus H12 divided by H11 and H21 divided by H11, and the final element H11 H22 minus H12 into H21 divided by H11. So, well, coming to now ABCD parameter in terms of Z parameters. So, Z parameters equation are given like V 2 equal to Z 2 1 I 1 plus Z 2 2 I 2, and from which we can find out typical value of I 1 from here, dividing this equation taking other side. So, I 1 will be 1 upon Z 2 1 V 2 plus Z 2 2 divided by Z 2 1 into minus I 2, and V 1 equal to Z 1 1 I 1 plus your Z 1 2 I 2. So, that gives us V 1 equal to Z 1 1, putting a value of I 1 from this previous equation, 1 upon Z 2 1 V 2 plus Z 2 2 divided by Z 2 1 into I 2 plus Z 1 2 I 2. So, from this we can say this typically your here V 1 will be equal to Z 1 1 divided by Z 2 1 into V 2 plus minus I 2 into Z 2 2 Z 1 1 minus Z 1 2 Z 2 1 divided by Z 2 1, and comparing these two equations with the governed in terms of ABCD parameter, we can say write A equal to Z 1 1 upon Z 2 1, B equal to Z 2 2 Z 1 1 minus Z 1 2 1 Z 1 2 Z 2 1 divided by Z 2 1, and C equal to 1 upon Z 2 1, and D equal to Z 2 2 upon Z 2 1. And now, in matrix form we can write these your transmission parameter A B C D equal to Z 1 1 divided by Z 2 1 and Z 2 2 Z 1 1 minus Z 1 2 Z 2 1 divided by Z 2 1, and 1 upon Z 1 1 and Z 2 2 divided by Z 2 1. Now, writing this ABCD parameter in terms of Y parameters. So, Y parameters equation given by I 2 equal to Y 2 1 V 1 plus Y 2 2 V 2, from which we can find out now V 1 equal to minus Y 2 2 upon Y 2 1 into V 2 minus in bracket minus 1 upon Y 2 1 into minus I 2, or we can say V 1 equal to minus Y 2 2 upon Y 2 1 V 2 minus in bracket minus 1 upon Y 2 I 2, and I 1, the second equation of Y parameter is I 1 equal to Y 1 1 V 1 plus Y 1 2 V 2, from which we can give the value of V 1. So, here it will Y 1 in bracket minus Y 2 2 upon Y 1 2 into V 2 plus 1 upon Y 2 2 I 2 plus Y 1 2 V 2, and that is equal to your Y 1 1 Y 2 2 minus Y 1 2 Y 2 1 divided by Y 2 1 into V 2 plus minus Y 1 1 divided by 1 2 1 into minus I 2, and that becomes equal to your in bracket Y 1 1 Y 1 2 2 minus Y 1 2 into Y 2 1 divided by Y 2 1 V 2 minus in bracket minus Y 1 1 divided by Y 2 1 into I 2. And from these comparing these two equations, we can say A parameter here is minus Y 2 2 divided by Y 2 1, and B parameters is minus 1 upon Y 2 2 Y 2 1, and C parameters is your Y 1 1 into Y 2 2 minus Y 1 Y 2 Y 1 2 Y 2 1 divided by Y 2 1, and D parameter is your minus Y 1 1 divided by Y 2 1, and in matrix form this transmission line parameters in admittance parameters will be like A B C D equal to minus Y 2 2 divided by Y 2 1 and minus 1 upon Y 2 1 Y 1 1 into Y 2 2 minus Y 1 2 into Y 2 1 divided by Y 2 1 minus Y 1 1 divided by 1 Y 2 1. Now, coming to this ABCD parameter in terms of H parameters. So, from the governing equation of H parameter we can write I 2 equal to H 2 1 I 1 plus H 2 2 V 2, and from this equation we can write the equation for I 1, that is equal to minus H 2 2 divided by H 1 1 H 2 1 into V 2 and plus minus 1 upon H 2 1 into minus I 2, and from the another equation of V 1 equal to H 1 1 I 1 plus H 1 2 V 2, from which we can write V 1 equal to H 1 1 in bracket minus H 2 2 divided by H 2 1 into V 2 plus in bracket minus 1 upon H 2 1 into minus I 2 and close bracket close, then H 1 2 into V 2. Then solving it, the equation becomes 1 V 1 equal to in bracket minus H 1 1 H 2 2 minus H 1 2 to H 2 1 divided by H 2 1 into V 2 minus in bracket minus H 1 1 divided by H 2 1 into Y 2. So, comparing these two equations with original ABCD parameter. So, this A parameters becomes minus H 1 1 H 2 2 minus H 1 2 into H 2 1 divided by H 2 1, and B parameter is minus H 1 1 divided by H 2 1, and C parameter is minus H 2 2 divided by H 2 1, and D parameter is minus 1 upon H 2 1. And this ABCD parameters, transmission line parameter of ABCD in terms of hybrid parameters is minus H 1 1 H22 minus H12 H21 divided by H21 and minus H2 H11 divided by H21 and minus H22 divided by H21 and minus 1 upon H21. Well, now the H parameters in terms of Z parameters. So, utilizing the governing equation of your Z parameters. So, V 2 equal to Z21 I1 plus Z22 I2, or we can write from this equation the equation for I2 equal to minus Z21 upon Z22 into I1 plus 1 upon Z22 into V2, and from the first equation V1 Z11 I1 plus Z12 V I2. From here we can write like V1 equal to Z11 I1, and we can keep the value of from this equation of I2, we can write Z12 in bracket minus Z21 upon Z22 I1 plus 1 upon Z22 into V2, and simplifying this equation we can write here V1 equal to Z11 into Z22 minus Z12, Z21 divided by Z22 into I1 plus Z12 divided by Z22 into V2, and comparing these two equations, the H parameters of the network in terms of impedance parameter is your H11 equal to Z11 Z22 minus Z12 Z21 divided by Z22, or H12 equal to Z12 divided by Z22, or H21 equal to minus Z21 upon Z22 and H22 equal to 1 upon Z22. Now, in this matrix form, this is your hybrid parameters now H11, H12, H21, H21, H22 virtually it will be equal to your Z11, Z22 minus Z12, Z21 by Z22 and Z12 divided by Z22 and minus Z21 divided by Z22 and 1 upon Z22. So, now H parameters in terms of Y parameters. So, governing equation for Y parameters is already there, I1 equal to Y11 V1 plus Y12 V2 and I2 equal to Y21 V1 plus Y22 V2. So, first equation we can find out V1 from that by dividing entire equation by Y11. So, V1 becomes 1 upon Y11 into I1 plus Y12 Y11 into V2, and from the second equation of I2 equal to Y21 V1 plus Y22 V1, we can find out typically your V2 equal to Y22 upon Y11 into I1 plus Y11 minus Y11 into Y22 minus Y12 Y21 divided by 11 V2, and comparing these two equations we can get H parameters in terms of Y parameter H11 equal to 1 upon Y11 and H12 Y12 upon Y12 upon Y11 and H21 Y2 upon Y21 upon Y1 and H22 equal to Y11 into Y22 minus Y12 Y21 divided by Y11, and in matrix form we can write this hybrid parameters in terms of admittance parameter like H11 H12 and H21 H22 equal to 1 upon Y11 in Y12 upon Y11 and Y21 divided by Y11 and Y11 into Y22 minus Y12 Y21 divided by Y11. Then H parameters in terms of your ABCD parameters. So, the ABCD parameters equation is given like I1 equal to C VT2 minus D VT2, and the from which we can find out I2 by dividing D in this equation and taking other term to other side. I2 equal to minus 1 upon D into I1 plus C upon D V2, and from second equation of this V1 equal to A V2 minus V I2. So, we can get V1 from here A V2 minus B in bracket minus 1 upon D I1 plus C upon D V2, and from which we can find out V1 equal to B upon D I1 plus AD minus BC upon D into V2, and comparing these two equations we can get H parameters in terms of transmission line parameter. So, H11 equal to B upon D and H12 equal to AD minus BC upon D and H12 equal to minus 1 upon D and H22 C upon D. And now, this hybrid parameter in terms of transmission line parameter. So, it is H11 H12 H21 H22 equal to B upon D and AD minus BC upon D and 1 as minus 1 upon D and C upon D. Now, coming to parameter conversion, after looking all these so many conversions, we can say all parameters, if all parameter exist, they can be related by conventional algebraic manipulation. And an example, consider the relation between Z and Y parameters. So, we know the Z parameters equation like V1 V2 V1 equal to Z11 I1 plus Z12 I2 and V2 equal to Z21 I1 plus Z22 I2. So, this we can write in a matrix form V1 V2 equal to Z11 Z12 Z21 Z22 into I1 and I2 matrix, and where the I 1 I 2 can be inverse of Z matrix into V 1 V 2, or we can write it as a y 1 1 y 1 2 and y 2 1 and y 2 2 into V 1 V 2. So, we can say you can call it y 1 y matrix is inverse of Z matrix, and that we can written equal to 1 upon delta Z equal to y 2 2 minus y 1 Z 1 2 minus Z 2 1 Z 1 1, where Z delta Z is Z 1 1 Z 2 2 minus Z 2 1 Z 1 2. This is the, you can call it conversion from your Z parameters to Y parameters. And in the following conversion table, the symbol delta stand for the determinant of the corresponding matrix, that delta Z equal to Z 1 1 Z 1 2 Z 2 1 Z 2 2. Similarly, delta Y is Y 1 1 Y 1 2 Y 2 1 and Y 2 2. I mean, you say determinant of matrix Y, and delta H equal to H 1 1 H 1 2 H 2 1 and H 2 2, and delta T A B C D determinant of ABCD. And now coming to two port parameters conversion formula. So, this is the matrix, you will say 4 by 4 matrix, and we can here like a Z 1 1 equal to delta H upon H 2 2. So, typically if you want to find out, I mean, you can call it Z parameters in terms of H parameters. So, you can have this matrix in this form. So, to get the Z 1 parameter H parameter, to get the one set of parameters to another set, locate the set of parameters you want to move along with the vertical up, and you are in the row that contains the parameters you want to convert to the compare of this. So, it is something we want to convert this H parameters into Z. So, we go into the same typically the column, and this is your Z parameters in this. So, you can apply for similarly for other one. I mean, if you want to really convert like a typically Y parameters into typically the Z parameters, so you can come to here. So, this way you can have a conversion. So, this is a conversion of your 4 by 4 typically Z to Y or transmission or hybrid parameters. So, table conversion table between Z, Y, ABCD and H parameters 2 port network. Similarly, we have a this conversion of 6 port network. So, table containing conversion table of all 6 port network like Z, Y, ABCD transmission parameters, inverse transmission parameter, inverse your Y parameters and inverse your hybrid parameters like. So, here you can say typically it is written your Z, Y, H, G, T and small t, and similarly on the row side also it is your all 6 Y, H, G, T and small t. So, you can just have a Z parameters in terms of all 5 parameters, these are given here, and similarly Y may be here in terms of again Z and all that. So, this is 6 by 6 which of course have a determinant of all 6 matrix which are explained here. So, this is the total conversion from your 6 to 6 conversion, or you can call it one set of parameter to others 5 set of parameters like in this table. And like interconnection of 2 port network, coming to how we can interconnect the 2 port network in many ways, because there may be like a many 2 port network which maybe need to combine, I mean when you are solving the big network. So, here we have an example how we can have a 2 port network can be combined, and the same way probably we can go for large complex circuit also. So, just to give an example. So, there are 5 way of 2 port may be interconnected. One is series, you can have a 2 port connected in series or 2 port connected in parallel, or 2 port connected in series parallel, or connected in 2 port 2 network in parallel series, and 2 port can be connected in cascade. So, these are the 5 way how we can connect 2 sets of parameters typically of. Now, coming to first interconnection of 2 port network with the series connection. So, you have a 2 network here, or you can call it 2 network of 2 port, and they are connected in series. So, you can see on input side the both voltage are connected in series, but we will have a common current, and output side also have a 2 voltage are connected in series and current is common. So, that is the basic concept, that we have a voltage are added, current is the same in the input as well as output in series connection. So, when the networks are connected in series, their individual Z parameters add up to give their Z parameters of the large network. So, we can say if we talk about the equation 2 equations in terms of V 1 V 2 as a Z matrix Z 1 2 Z 1 1 Z 1 2 Z 2 1 Z 2 2 in terms of I 1 I 2, you can write it as Z into I 1 I 2. Similarly, you can write this scalar form the both the network equation V 1 A equal to Z 1 1 A I 1 A plus Z 1 2 A into I 2 A, and V 2 A equal to Z 2 1 A I 1 A plus Z 2 2 A I 2 A, and for network B we can write the another set of equation where V 1 B equal to Z 1 1 B I 1 B plus Z 1 2 B I 2 B, and V 2 B equal to Z 2 1 B I 1 B plus Z 2 2 B into I 2 B. So, referring to the figure, we can say by interconnection where I 1 equal to I 1 A and equal to I 1 B, because input port are connected in series, and similarly I 2 will be I 2 A equal to I 2 B, because output port also connected in series. And we can say the V 2 equal to V 2 A plus V 2 B, and V 1 is also sum of your V 1 A plus V 1 B. That is here V 1 equal to V 1 A plus V 1 B. So, we can write from this V 1 equal to, putting a value of V 1 A, that is Z 1 1 into A I 1 A plus Z 1 2 into A I 2 A plus Z 1 1 B into I 1 B plus Z 1 2 B into I 2 B, that is equal to I 1 into in bracket Z 1 1 A plus Z 1 1 B plus I 2 Z 1 2 A plus Z 1 2 B, and we can say V similarly we can say V 2 equal to V 2 A plus V 2 B, that is V 2 equal to, putting the value of this here. So, Z 1 2 A I 1 A plus Z 2 2 I 2 B 2 A plus Z 2 1 B I 1 B plus Z 2 B 2 2 B plus I 2 into I 2 B equal to V 2 equal to I 1 in bracket Z 2 1 A plus Z 2 1 B plus I 2 in bracket Z 2 2 A plus Z 2 2 B. Thus, we get for the series connected two numbers of two port. So, we can where we can write V 1 equal to I 1 in bracket Z 1 1 A plus Z 1 1 B and plus I 2 in bracket as Z 1 2 A plus Z 1 2 B, and V 2 equal to I 1 in bracket Z 1 Z 2 1 A plus Z 2 1 B plus I 2 in bracket Z 2 2 A plus Z 2 2 B, or in matrix form we can write V 1 equal to your in terms of I 1 I 2 is your Z 1 1 A plus Z 1 2 B plus Z 1 into Z 1 2 A plus Z 1 2 B and Z 2 1 A plus Z 2 1 B and Z 2 2 A plus Z 2 2 B. So, that is the how in interconnection. Now, we have a interconnection in parallel connection where the input and output port are connected in parallel. So, in this case voltage will of the both the port will be the same, but current will be shared in the both input current and output current will be shared between the two ports. So, we can say when interconnected network is in parallel, so individual y parameters add up to give the y parameters of the large network. So, we can say V 1 V 2 equal to Z 1 1 Z 1 2 Z 2 1 Z 2 2 I 1 or I 2 equal to y I 1 I 2, and we can say here in terms of for network A we can write this in terms of admittance I 1 A equal to y 1 1 A plus into V 1 A plus y 1 2 A V 2 A and I 2 A equal to y 2 A V 1 A plus y 2 2 A into V 2 A. For network B we can write I 1 B equal to y 1 1 B V 1 B plus y 1 B y 2 1 B V 2 B and I 2 B equal to y 2 1 B y 1 B plus y 2 2 B into V 2 B. And for parallel connection we can say V 1 equal to V 1 A equal to V 1 B, and similarly V output port V 2 equal to V 2 2 V 2 A equal to V 2 B and I 1 equal to I 1 A plus I 1 B and I 2 equal to I 2 A plus I 2 B, and from which we can find out here I 1 A equal to I 1 A plus I 1 B, and we can put the value of both these two currents. So, I 1 net current will be I 1 equal to y 1 1 A V 1 A plus y 1 2 A V 2 A plus y 1 1 B into y 1 V 1 B plus y 1 2 B into V 2 B equal to V 1 in bracket we can say y 1 1 A plus y 1 2 B and plus V 2 y 1 2 A plus y 1 2 B and I 2 equal to I 2 A plus I 2 B, that is I 2 equal to putting a value of I 2 A and 2 B, it is like in bracket y 2 A V 1 A plus y 2 2 A V 2 A plus y 2 1 B V 1 B plus y 2 2 B into V 2 B, that I 2 becomes finally V 1 into y in bracket y 2 1 A plus y 2 1 B and plus V 2 into y 2 2 A plus y 2 2 B. So, where the final equation is I 1 equal to V 1 into in bracket y 1 1 A plus y 1 1 B plus V 2 2 y 1 2 A plus y 1 2 B and I 2 equal to V 1 in bracket y 2 1 A plus y 2 1 B and plus V 2 equal to in bracket y 2 2 A plus y 2 2 B, or in matrix form this I 1 I 2 can be expressed in terms of V 1 V 2 and the elements of this Y matrix becomes combined form y 1 1 A plus y 1 1 B plus the another element is y 1 2 A plus y 1 2 B and y 2 1 A plus y 2 B and y 2 2 A plus y 2 2 B. So, now coming to the third interconnection of two port network like a cascade connection, when the two networks are connected in cascaded form, their individual transmission parameter can be multiplied together to get the transmission parameter of the large network. So, transmission parameters we can write the equation V 1 I 1 in terms of V 2 minus I 2 A B C D, or we can say T into V 2 minus I 2, and here it is a cascading of two port network of N A and B. We are connecting cascading form. So, we can say the input current is I 1 equal to I 1 A and V 1 equal to V 1 A, and in between we can say I 2 equal to minus I 1 B and V 2 A equal to V 1 B of second port network and I 2 V 2 equal to I 2 B and V 2 B. Now, in this of course, for this cascading we take it becomes simpler in transmission parameter. So, we can write the equation in transmission for network A for transmission parameter form. So, V 1 A and I 1 A in terms of your V 2 A minus I 2 A in terms of ABCD parameter like AA, BA, CA and DA, and for network NB we can write this 1 V 1 B I 1 B as a function of V 2 B minus I 2 B in terms of AB, PB, CB and DB. And now, we form this, we form the figure, we can say where V 1 I 1 equal to V 1 A I 1 A and V 2 A minus I 2 A equal to V 1 B and I 1 B and V 2 B and minus I 2 B equal to V 2 minus I 2. So, substituting these from one equation to another. So, V 1 I 1 becomes in terms of the V 2 minus I 2 as a parameter of AB's first network and AB network, just to multiply that A 1 AA, BA, CA, DA into AB, BB, CB and DB, and transmission parameter for overall network is a product of individual transmission parameter like ABCD equal to A, B, BA, CA, DA into AB, B, CB, DB, or we can say T equal to TA into TB. Now, coming to series parallel connection of interconnection of two network NA and B. So, here we are connecting series parallel in the sense the input is connected in series, as you can see here the current is same in both, but the voltage are added and output we are connecting them in parallel. So, V 2 is same, but current is divided into two parts like. So, now in this case we can write the equation for input port and output port. So, V 1 equal to V 1 A plus V 1 B, but I 1 equal to I 1 A I 1 B, and for output connecting them parallel. So, V 2 is V 2 A and V 2 B and I 2 is sum of your I 2 A plus I 2 B, and we can say in matrix form this becomes easier in H parameter hybrid parameter. So, H equal to H A plus H B. And now, coming to interconnection of your parallel series connection. So, that is input we are connecting in parallel, the voltage is equal, but current is divided into two parts, and output are connected in series, that has given parallel series configuration. So, V 2 is equal to I 2 equal to I 2 A equal to I 2 B. So, this we can write V 1 equal to V 1 A equal to V 1 B and I 1 equal to I 1 A plus I 1 B and V 2 equal to V 2 A plus V 2 B and I 2 equal to I 2 A I 2 B, and in matrix form this easily comfortable represented in terms of your inverse H parameter that we call G parameter. So, G equal to G A plus G B. So, these are the how we are really cascading in 5 way. Now, coming to quick quiz questions. So, if the two ports are connected in cascade configuration, then which arithmetic operations should be performed between the individual transmission parameter in order to determine addition, solution, multiplication, division. So, it comes multiplication we already discussed, and two ports are connected in parallel. So, the combination can be represented in single port network. The parameters of are obtained in that Z parameter, Y parameter and Z parameter and T. So, these typically Y parameters like. And now, coming to some solved examples, solved numerical problems. So, starting from question 1 as a example 1, find the Z parameters of the network. So, here we have a network with R 1, R 2 and R 3 T network with a V 1 I 1 as input voltage and current and I 2 V 2 as output. So, this we can have a equation by mesh current solution as a R 1 plus R 2 R 2 R 2 plus R 2 plus R 3 into I 1 I 2 equal to V 1 upon V 2 from these two loop equations. So, where we can say now Z parameter will be Z from this matrix form, we can write Z 1 1 equal to R 1 plus R 2 and Z 1 2 Z 2 1 R 2 and Z 2 2 R 2 plus R 3 and from just comparing from this Z parameters equation. And two port network can be replaced now equivalent circuit. Here we have a V 1 I 1 with a parameter Z 1 1 and a dependent voltage source, current dependent voltage source of secondary side current. So, Z 1 2 I 2 with the plus minus. Similarly, output side we have a V 2 I 2 as a impedance parameter Z 2 1 and a voltage source of a dependent voltage source Z 2 1 I 1 and the equation we can write here V 1 equal to Z 1 1 I 1 plus Z 1 2 I 2 and V 2 equal to Z 2 1 I 1 plus Z 2 2 I 2. And in the two port is a, if the two port reciprocal Z 1 2 equal to Z 2 1, then we can also represent this T in terms of T network. So, where you can say V 1 and V 2 can be represented in terms of like Z 1 1 minus Z 1 2, Z 2 2 minus Z 1 2 and the common impedance is Z 1 2. So, now coming to question 2, find the Z parameters of a network given here with the typically of 2 ohm and 10 ohm input output and with the your pi network of 6 ohm, 4 ohm and 8 ohm and assign mesh current as followed and write down the mesh equation. So, from this from 3 I mean typically loops we can have a 3 equation here in terms of V 1, V 2 and V 0 because input mesh have a with the V 1 source and output have a V 2 source with the 3 currents of I 1, I 2, I 3 and there is no virtually for input I 3 current. So, starting from first, so first have a like a 2 plus 4 ohm and there is no interconnection between the typically you can say first to third loop, second loop. So, it is a 0 and first and second is a 2 currents are opposite. So, minus 4 and then again 0 typically from second to you can call it here then 10 plus 8 that is typically your total impedance where I 3 I 2 is moving between the 2 and 8 is the common between I 2 and I 3 and then minus 4 and 8 this. So, we can say these parameters we can write ABCD for I 1 I 2 and V 1 V 2 keeping I 3 equation separate. So, we can say now A is I 1 I 2 plus B I 3 that is V 1 V 2 and C I 1 I 2 plus D I 3. So, we can say I 3 is minus D 1 D inverse into C in I function of I 1 I 2 and we can say from one equation A I 1 I 2 minus B D inverse C I 1 I 2 or we can say in bracket A minus B D inverse C and I 1 I 2 equal to V 1 V 2 or we can say Z parameters is your A minus B D inverse C. So, now coming to the question 3, find the Z parameters of the following circuit by definition of Z parameters where we have a pi network of 3 resistance of 4, 8 and 8 ohms where input voltage and input current is V 1 I 1 and output voltage V 2 I 2 and from this we can have a same method that we keep first output port open and we can find out like I 1 as a function of your typically V 1 divided by the entire resistance of 8 in series and parallel of ohm. So, it becomes 20 by 64 V 1 and V 2 typically we can find out what is the voltage across 8 ohm. So, that is 8 divided by the current flowing into 8 plus 8. So, that is your V 1 into 1 by 2 V 2 and from which we can write Z 1 1 equal to V 1 upon I 1 equal to 60 by 20 and equal to 16 by 5 ohm and Z 2 1 equal to V 2 upon I 1 that is half V 1 upon I 1 that is half Z 1 1 equal to 8 by 5 ohm. And now keeping a input port open to get the other two parameters I 1 equal to 0 and applying for V 2. So, I 2 is equal to V 2 upon now this your 8 4 ohm is in series with parallel of 8 ohm that is 5 by 24 into V 2. So, V 1 becomes 4 upon 4.8 V 2 plus 4 plus 8 V 2 or 1 by 3 V 2 or Z 2 2 is V 2 I 2 that is your 24 by 5 and Z12 V1 I2 equal to 1 by 3 V2 upon I2 equal to 1 by 3 Z22 equal to 8 by 5 and Z matrix is now 16 by 5, 8 by 5, 8 by 5 and 24 by 5 ohms. Now, to coming to example 4, given Z parameters, find H parameters. The form we can say step 1 V1 in terms of Z parameter is your Z11 I1 plus Z12 I2 and V2 equal to Z21 I1 plus Z22 I2. So, in this standard form we can say 1 Z1 minus Z11 I1 plus 0 V2 minus Z12 I2 equal to 0, 0 V1 plus Z21 I1 minus 1 V2 plus Z22 I2 equal to 0, and from which we can have a step 2. We can write this equation in form of your typically your V1 I2 in terms of I1 I2. So, that is 1 minus Z12 0, Z22 equal to Z11 0 and minus Z21 I1 in I1 into V2. So, solving this we can find out your V2 V1 I2, that is V1 I2 will be equal to your taking inverse of this matrix on other side. So, 1 minus Z12 0 Z22 inverse multiplied Z11 0 minus Z12 1 into I1 Z2, or we can say V1 I1 equal to your H11 H12 H21 H22 I1 V2, and from which we can find out now the equation V1 equal to Z11 I1 plus Z12 V2 and I2 and V2 equal to Z21 I1 plus Z22 I2, and from second equation we can obtain I2 equal to minus Z21 Z22 I1 plus Z1 V2 upon Z22 or H21 I1 plus H22 I2. So, taking from this A and C equation we can say V1 equal to Z11 I1 plus Z12 in bracket H21 I1 plus H22 I2 equal to Z11 plus Z12 H21 into I1 plus Z12 H22 into I2, and that is equal to H1 I1 your H12 V2. So, question example 5, the Z parameter of circuit is given 4133 and obtain the transmission line parameters. So, we can write the equation for Z parameters V1 equal to 4 I1 plus I2 and V2 equal to 3 I1 plus 3 I2. So, from this equation second we can write I1 equal to V2 by 3 plus in minus I2, and we can write from equation 1 V1 equal to 4 in bracket V2 by 3 plus minus I2 plus I2, or we can write V1 equal to 4 by 3 V2 plus 3 in bracket minus I2, and rearranging the equation 3 and 4. So, we can write V1 I1 equal to 4 by 3 3 and 1 by 3 1 V2 minus I2, or this give us parameters ABCD parameters as 4 by 3 3, 1 by 3 and 1. So, now coming to question 6, in the network shown here, find the transmission line parameters. So, it is given only one impedance ZL. So, we can say here solution of loop equation V1 equal to ZL into I1 plus I2 equal to ZL I1 plus ZL I2, or V2 equal to ZL I1 plus I2 equal to ZL I1 plus ZL I2, or we can write V1 V2 in equal to ZL all parameters ZL into V1 V2 into I1 I2, and hence Z parameter becomes your ZL 1 1 1 1. Hence, the transmission line parameter can be written 1 upon Z21 Z11 delta Z I1 Z22 equal to 1 0 and 1 upon ZL into 1, where Z equal to delta Z equal to Z11 Z22 minus Z12 Z21 equal to 0. Now, coming to the question 7, find the Y parameters of the network. Their network is shown here, where we have a 3 resistances in T network 1 2 1, and in parallel of upper branch it is a minus 2 J 2 ohm. Now, we can consider these two networks connected in parallel. So, as you can see here equivalent how they are connected, two network, one consisting of your 1 2 and 1 ohm, another is minus 2 J 2 ohm. So, from which we can find out like your typically V1 from first network we can say V1 minus V2 equal to minus J 2 I1 and I2 equal to minus I1, and we can from here we can write the admittance Y11 equal to minus equal to J by 2 and Y12 equal to minus J by 2 and Y2 equal to minus J by 2 and Y22 equal to J by 2, and from which we can find out the Y parameters of this network become 3 by 5 plus J12 and minus 1 by 5 plus J by 2 and minus 1 by 5 plus j by 2 or 2 by 5 plus j by 2. And typically your second net, that was first network, and second network is typically V 1, 1 ohm, 2 ohm and 1 ohm as a V 1 V 2. So, from which we can write as a equation here V 1 equal to 2 I 1 plus I 2 and V 2 equal to I 1 plus 3 I 2, or we can say Y B matrix will be inverse of this impedance matrix of 2 1 1 3, and that will become a typically 1 upon 5, that is the determinant of this, and in bracket it will be 3 minus 1 2, and from this we can have a typically network coming to simplified 2 network here, that is typically the final equation. And now question 8, find the Z parameters for the network. Here we have a network, again same network, and we have this network connected for network A and network B. We can represent this network dividing into 2 parts, that these 2 we can typically take as equivalent to, and use direct method, give the Y parameter transform to, or decompose the network into series or similar parallel. So, we can have a Z equal to 2 minus 2 j by 3 minus 2 j and 2 upon 3 minus 2 j, 2 upon 3 minus 2 j, and 2 minus 4 j divided by 3 minus 2 j, and Z b is all 1 1 1 element, and where Z becomes Z a plus Z b. So, you can add together. So, that becomes your 5 minus 4 j upon 3 minus 2 j, and second element 5 minus 2 j upon 3 minus 2 j, and 5 minus 2 j upon 3 minus 2 j, and 5 minus 6 j upon 3 minus 2 j. Now, coming to question 9, determine the Z, Y, T and H parameters of the network shown here, where only one impedance is shown in series Z. So, we can say the solution of loop equation V 1 equal to V 2 plus I 1 Z and I 1 equal to minus I 2. So, Z parameters they do not exist, since I 1 I 2 are not independent. So, I 2 equal to 0, so I 1 is also equal to 0, vice versa. So, Y parameter will be like I 1 upon Y 1 V 2 0, that is 1 upon Z, and Y 2 1 I 2 upon V 1 V 2 equal to 0, that is minus 1 upon Z, and Y 1 2 equal to I 1 upon V 2 V 1 0, that is minus 1 upon Z, and Y 2 2 equal to I 2 upon V 2 equal to 1 upon Z. So, we can say Y parameters will be here 1 upon Z, minus 1 upon Z, minus 1 upon Z, and 1 upon Z, and T parameter will be A equal to V 2 upon V 1, I 2 equal to 0, that is your 1, and C parameter I 1 upon V 2 I 2 equal to 0, that is 0, and B parameter V 1 upon minus I 2 V 2 0 Z, and D is I 1 minus I 1 divided by minus I 2 V 2 0, that is 1. So, T parameters here becomes 1 Z 0 1, and H parameters here for this will be H 1 1 V 1 upon I 1 V 2 0 Z, and H 2 1 will be I 2 upon I 1 V 2 0, that is minus 1, and H 1 2 V 1 upon V 2 equal to Z, and H 2 2 will be I 2 upon V 2 I 1 0 equal to 0. So, the H parameter matrix will be your Z 1 minus 1 0. So, coming to question 10, find the Y parameters of the 2 port. Here 2 ports are connected in parallel, N A and B, the 2 networks are connected in parallel. So, comparing N A and B in the circuit, so Y 1 A is minus 4 equal to Y 2 1 A, and Y 1 1 is 2 plus J 4, that is Y 1 1 A equal to 3 plus Z 4 from typically from this network, and we can say Y A equal to 2 plus J 4 minus J 4 minus J 4 3 plus J 4 Siemens, and Y 1 2 B is minus 4, and Y equal to Y 2 1 B, and Y 1 1 B equal to 4 minus J 2, and Y 1 1 B equal to typically your 4 minus J 6. So, or we can say Y B equal to a matrix 4 minus J 2 B minus 4 and 4 minus J 4, and then 2 overall Y parameter will be Y equal to Y A plus Y B, and that becomes your 6 plus 2 J minus 4 J 4, and minus 4 minus J 4, and 7 minus J 2. So, these are some unsolved problem, which you can exercise in the same way 3 4, and these are the of course, the references from which we have developed this lecture material, and thank you very much.